In Lesson 2.2, you will be comparing and ordering rational numbers. In our first example, we have two fractions that we are going to compare. If you want to compare two fractions, one way to do it is to rewrite the fractions with a common denominator. 8 and 4 both go into 8, so I'm going to leave the first fraction as it is, 5/8. And the second one I'm going to rewrite with an 8 in the denominator, which means since I multiplied the denominator by 2, I'd have to multiply the numerator by 2 to keep it so it's equivalent to 3/4. Now 5/8 and 6/8 can be compared. 5/8 is less than 6/8, therefore 5/8 is less than 3/4. Now at some point you may have learned how to compare fractions by using what some teachers call the butterfly method. The butterfly method is just multiplying diagonally. Let me rewrite this problem again. 5/8 and 3/4. If I were to go now and multiply diagonally, 8 times 3, 8 times 3 is 24, and 5 times 4 is 20. 20 is less than 24, therefore 5/8 is less than 34. What you were really doing with that shortcut method is writing it with a common denominator without actually taking the time to write that common denominator down. What we used in this example was actually 32 as a common denominator because 8 times 4 is 32. And then to rewrite 5/8 with 32 in the denominator, you multiply by 4. So multiply the numerator by 4. 5 times 4 is 20. And then to go from 4 to 32, we multiplied by 8, and 3 times 8 is 24. So when we got 20 and 24 multiplying diagonally, it really was the numerators in these two fractions that have the same denominator. And again, 20 30-seconds is less than 24 30-seconds. So 5/8 is less than 3/4. When you're working on your homework, you can either just rewrite them with a common denominator, or if you want to use the butterfly method, that's fine too, as long as you're writing down what you're doing. 4 times 7 is 28. 12 times 3 is 36. 36 is greater than 28, so 3/4 is greater than 7/12. In our next example, 6 times 7 is 42. 8 times 5 is 40. 40 is less than 42, so 5/6 is less than 7/8. In this last example, we have some mixed numbers, but they both have a 1 here, so we really just have to compare the 4/9 and 2/5. If I compare the 4/9 and 2/5, 9 times 2 is 18, and 5 times 4 is 20. 20 is more than 18, so 1 and 4/9 is greater than 1 and 2/5. Another way you can compare fractions is to change them to decimals. This is especially easy when we get to the point where it's okay to use a calculator. But for now, in this chapter, we're not using a calculator, so we are either going to use long division, or it might be a fraction that we can figure out the decimal because it's one we already know. For example, 1/3, you may recall from last lesson, is 0.3 repeating. And if we want to compare that to 0.3, since this is a repeating 3, it's going to keep going with 3's, where this other number is going to have zeros after it. So if I wanted to start comparing, I have a 3 and a 3, and then I have a 3 and a 0. 3 is bigger than the 0 in the hundredths place there. So 1/3 is greater than 3/10. Next example, I could go and divide 11 by 50 to figure out what that is as a decimal, Or I might recognize that 11/50ths is the same thing as 22/100ths. If I multiply the numerator and denominator by 2, and 22/100ths written as a decimal looks just like it sounds, 22/100ths. And since we have 22/100ths on the left and 22/100ths on the right, these two are equal. Now on to the next example. They both have a 2, but now we have 42/100ths and 5/12ths. If I'm not sure which is bigger, and I don't know the decimal equivalent of 5/12ths off the top of my head, so I'm going to go ahead and do 5 divided by 12. 12 doesn't go into 5, so I add a decimal point and a 0, put the decimal straight up. 12 goes into 50 4 times. 4 times 12 is 48. 50 take away 48 is 2. Add a 0, bring it down. 12 goes into 20 once, with 8 left over. And I could keep going here, but I really don't need to, because in the 100th spot, I have a 1 over here, and I have a 2 here. See the 1 and a 2? So this one, the 5/12ths, is smaller. Our third example wants us to put some numbers in order from least to greatest. If I take a look over here, all of my numbers are positive, and I can tell that I'm going to need to choose between this one and this one for the smallest. And while I could change the 4/5ths to a decimal and the 1/4 to a decimal, I also know just by looking at it that this one right here is the smallest, because 1/4 is less than a half and 4/5ths is more than a half. So I can tell just by estimating that this one here is going to be the smallest. When you write them out in order, you always write them out with the number that they give you in the problem, not what you change it to when you're comparing them. The second one is going to be the 74 4/5ths. Next, we're going to move on to the 75 and 75 1/3. Well, 75 is obviously smaller than 75 1/3. And then the largest is going to be 76 9/10. One good habit to get into when you're putting things in order like this is to count up how many numbers you have, and then make sure you have the same number of numbers in your answer so you don't forget anybody. Negative numbers, when you are comparing them, can get a little tricky. Thing to keep in mind is that the numbers furthest to the left on a number line are always going to be the smallest. One way to think about it is, if you were to ignore the sign, the number that's the biggest is actually the smallest when we're talking about negatives. For example, -2 4/10 and -2 45/100. If you were to put them on a number line, here's -2 4/10, and here's -2 4/5. -2 4/5 is the one furthest to the left on the number line, so that one's going to be the smallest. When you write your inequality sign, it's always pointing at the smallest one and eating the bigger number. If you were just to compare these without a number line, you might want to add a 0 after that so you can compare. We have 40/100ths and 45/100ths. 45/100ths is bigger, but since we're talking about negatives, that means it's just going to be further over to the left, so therefore it's actually the smaller one. With our last example, we have two negative fractions. They already have a common denominator, so I can go ahead and just compare them. I have 7/8 and 6/8, but they're both negative. 7/8, if we were talking about positive numbers, 7/8 is bigger than 6/8. But now since it's negative, it's actually going to be further to the left. It's going to be more negative. So that's actually going to be our smaller number. -7/8 is less than -6/8. The biggest thing to remember with negatives is it's really the opposite of what it would be if they were positives.